All right. Come on, lamp. There's the lamp. All right. So we have this. Can we solve this problem? Why not? There's nothing equal to anything, so we can't solve it. The only thing we're going to be able to do to it is simplify it. And so therefore, to simplify it, what that means is it's going to combine the fraction and get it underneath one fraction. Okay? And so the only concept that you have to know about adding and subtracting rationals is that you've got to have a common denominator. And so as I'm looking at this, there's not one single number that can be common between them. So the denominators combined together is the only thing that can be common. Okay, and so therefore, I know that my denominator is eventually going to be 4 times x minus 1, because I multiplied the two denominators together. Okay? And now some of you can think back to some of the other problems we worked. Well, sometimes we had denominators that were common, and I could just use it and start canceling and all this kind of stuff. I can't do one like every one that you're ever going to see, because as soon as I come up with 100 that I do, there will be 100 different ones out there. So you got to understand what the concept is. You got to learn is get a common denominator. And therefore, when I do that, I'm going to multiply the top by the same thing. So I'm going to multiply this by 4x times x minus 1, or 4 times x minus 1, and I'm going to multiply this by 4 times x minus 1. Okay? I'm going to multiply both of those. And so when I do it, I'm going to take that understanding and I'm going to move it down to this one that I was working with the common denominator. So what I'm left with is I have 6 times 4 times x minus 1 minus 5x times 4 times x minus 1.
Is there anything in it?
No?
Okay.
Is that the game thing you're talking about?
So what we're going to do is we're going to multiply all this together, and then we're going to do some canceling out. So if I multiply this side by it, up here at the top, this is going to be the piece that cancels out. The x minus 1 can cancel on that one, and on this side, the 4 can cancel on that one. All right, and so what I'm left with is I'm left with this common denominator here of 4x minus 1. So up here, when I multiply that, this is not going to need it because that was on that side, and this is not going to be needed because it was on that side. So really what happened is, as I was multiplying by that common denominator, I eliminated some of the other pieces. Okay? And so what I have left over here is I have 6 times 4, which is 24, minus 5x times x minus 1. And so this is going to become 5x squared minus 5x. And my bottom is going to be 4 times x minus 1. That's what I have so far. Okay? Everybody okay with me? All right? And so what we do now, we need to distribute our negative. So this is going to be 24 minus 5x squared plus 5x, because it changes it to a plus, all over 4 times x minus 1. All right? So I'm going to write that in order now so we can look at this quadratic. So it's 5x squared plus 5x plus 24 all over 4 times x minus 1. All right? So do we have anything we can do next? Do we have any GCFs in our top? Is there a GCF in the top at all? No GCF in the top? Huh? The X doesn't go all the way to the 24, does it? No? Can they factor the top?
Yes.
Y'all try to factor the top? We can try it. We can see. What's a way that I could test to see if the top would factor before trying to factor it? There you go. So let's look at that real fast. Okay, does everybody know what he's talking about, the discriminant? Yeah? Sort of, maybe, kind of, yeah? It's the b squared minus 4ac underneath the quadratic formula. If it comes out to be a what kind of number it can factor?
Perfect square.
Perfect square, even positive number. So don't forget that perfect square part. Okay? And so what would be my b? 5. So we got 5 squared minus 4 times, what's my a? Negative 5 times, what's my c? 24. Close that out. Hit equals. Is 505 a perfect square? How do I know? Second square root, second answer. Comes out to be a decimal. So is it factorable? It's not factorable. So what does that tell me? That I'm finished. Okay? That I'm finished. Now I could go ahead and multiply the bottom in there and get 4x minus 4. But this is my new combination of the two.